Hello, algebra class, and welcome to this video on section 7.5, factoring and solving quadratics. So in the past, we've seen an equation like this, and we want to solve for x. We know that there are going to be two answers, and we can find the GCF. The GCF is x. We can pull out an x and get x times x plus 8 is 0. So we're going to get our two answers of x is 0 or x plus 8 is 0, which means x is negative 8. And those are our two answers. But what happens if the actual equation looks like this? X squared plus 8x plus 15 equals 0. There is a zero product property, but if I throw the 15 over to the other side and get x squared plus 8x is equal to negative 15, there's no negative 15 product property. There's no rule that says that if I have two things that multiply together to get negative 15, that one of them has to be negative 15. So I'm going to need another way of doing this. And so we're going to have to kind of go back and think about what we've done in the past where we've seen quadratics like this, degree 2 trinomials. And what we've seen before is that this is usually the product of multiplying binomials together. So what I want to try to do is find two binomials that multiply together to get x squared plus 8x plus 15, because then what I would have is I would have two things that would multiply together to get 0. Remember, in the previous problem, we said that it's equal to 0. So if I can somehow turn this trinomial into the product of two binomials, then I can set those two binomials, multiply them together and set them equal to 0, and then use the zero product property. But the question is, how do I find two binomials that multiply together to get x squared plus 8x plus 15? All right, well, we do know that when we multiply binomials, we use FOIL. Let me actually just get rid of this. There we go. So how do I find out what those binomials are? Okay, my two first terms, here and here. Hopefully, we've practiced this enough. We know that if we multiply our two first terms in the past, we've gotten x squared. So what do our two first terms have to be in order to get x squared? Well, the likeliest candidate is x and x. So I'm going to bet that our two first terms are x and x because they multiply together to get x squared. Okay. Now, how about our last terms? What are our last terms going to multiply together to be? Our last term is going to multiply together to get 15. So we should start thinking about numbers that multiply together to get 15. It could be 1 and 15 or 3 and 5. And that's it. Okay, if this is going to break apart or factor nicely, and that's really what we're trying to do, we're trying to factor this trinomial. If this is going to factor nicely, then these last terms need to be nice numbers, and we shouldn't have something like square root of 15 and square root of 15 or 7.5 and 2 or anything like that. Okay, so before we guess as to which ones the last terms are going to be, let's think about our outer and inner term. Our outer and inner terms are usually something times x and something times x, and these combine. These are going to combine to get 8x. And when I say combine, I mean we're adding them together. So I'm looking for two terms that when I add them together, I'm going to get 8x. Now, where do these coefficients come from? It comes from the outer and inner. So there's the inner. And I usually draw that underneath now that I think about it. There's the inner. There's the outer. So x times this last thing plus x times this last thing, when I combine it, I should get 8x. So now I'm going to go back and look at these factors of 15. Which one will I use where my factors add up to 8? 1 and 15, they add up to 16. But 3 and 5, hey, that works. That adds up to 8. So I think our best bet is to say this is going to be a plus 3 and this is going to be a plus 5. And actually, if you switch those, doesn't really matter. We should get the, whoops, stay there, foil. We should get the same answer regardless. Let's just verify though, and not just hope that we're right. Okay, so I'll foil it, and I know x times x is x squared, so that part's good. My outer term, x times 3 is 3x. My inner term, 5 times x is 5x, and 3x plus 5x is 8x, so that works. And my last term, 5 times 3 is 15, so that works too. So it looks like the factored version of this trinomial is x plus 5 times x plus 3. And again, it does not matter which one you write first. Oops. Whether you write x plus 3 times x plus 5 or x plus 5 times x plus 3. It's a product. It doesn't matter. Okay, so now we can take a look at the equation that we had, x squared plus 8x plus 15 is equal to 0, and realize that I can turn x squared plus 8x plus 15 into x plus 3 times x plus 5. Let me actually do this. And now I can use the zero product property and say one of those two things is 0. Either x plus 3 is 0 or x plus 5 is 0. And if it's x plus 3, then I get x is negative 3. And if it's x plus 5, then I get x is negative 5. Okay, let's try a few more examples. Now, in these two problems, notice I'm not asking to solve. I'm saying I need to factor. And how do I know I'm not supposed to solve? Well, you solve an equation, and an equation needs an equal sign, and neither one of these have an equal sign. So all they want us to do is factor this trinomial. Okay, so I'm going to assume that it splits up into two binomials. And I'm going to get an x and an x because that's how I get x squared. And now I want two things that multiply together to get a positive 60, but combine to get a negative 16x. And really just the negative 16 is what I'm worried about. I'm looking for factors of 60 that when I multiply together get me a negative 16. And you're thinking, wait, how can it be negative? Well, when I think about two numbers that multiply together to get positive 60, yeah, positive times a positive is positive, but a negative times a negative is also positive. So something like negative 1 and negative 60 will multiply together to get positive 60, but they'll add to get negative 61. So that's no good. Now you could go through all of these if you want to. Negative 3 and negative 20, negative 4 and negative 15. And eventually you'll end on the right one, negative 6 and negative 10. That's the one where when I combine them, I get negative 16. So it looks like I'm going to say x minus 6 and x minus 10. And just to check it, I know if I FOIL, I'll get x squared minus 10x minus 6x is minus 16x plus 60. So I know that it works. Now, you don't have to go through the hassle of listing all of these factors. If you just go through your mind and rattle through them, look for the ones that add up to be 16. Okay. So you might heard this, you might see that I call this the sum product method. I'm looking for two numbers that have a product of 60 and a sum of negative 16. That's why it's called the sum product method, or you might hear me refer to it instead of sum product SP salt and pepper. You might say we're going to need to salt and pepper this. Salt, pepper, sum product. Okay, we're going to use the sum product method here too. So now I'm looking for two numbers that multiply together to get negative 14, but add to be a positive 5. All right. And again, I'm going to assume I get a binomial. I'm going to get an x and an x. I want two things that add to get 5 and multiply to get negative 14. If I multiply to be a negative, one has to be positive and one has to be negative. So really, I know this is a little confusing. It says sum, but if one's positive and one's negative, they're really going to subtract to be 5. So if you want to run through them in your mind, you can, but I'll tell you what the answer is. A positive 7 and a negative 2. A positive 7 and a negative 2 give me a negative 14. So I'm going to say x plus 7 and x minus 2. And that's how that breaks down. And if I want, I can check it. X times x, x squared, minus 2x plus 7x minus 2x plus 7x is a positive 5x minus 14. Okay. All right. Here it says factor completely. Now, what makes number 3 different? Number 3 has a leading coefficient that's not 1. What you might notice, though, is that each of these terms has a common factor. And that common factor is 3. So I can pull the 3 out of everything, and I'm left with x squared plus 7x minus 18. Okay, now I can use the sum product method on x squared plus 7x minus 18. I'm looking for two things that sum to 8 and have a product of negative 18. Remember, if it multiplies to be a negative, it has to be positive, one of them has to be negative. Since I want them to add up to be a positive 7, I know that the larger number needs to be positive. So if I did something like 2 and negative 9, they add up to be negative 7, and that's no good. So I'm instead going to use negative 2 and positive 9. Then they'll add up to be a positive 7. Okay, so my final answer is going to be the 3. I still have the 3. That doesn't change. X minus 2, x plus 9. And that is the full factored version of the original trinomial. Okay. The next one, you notice that, yep, once again, there's a common factor in each of the terms. This time it's an x. So I can pull an x out of everything, and I'm left with x squared minus 11x minus 26. Again, I'm going to look to salt and pepper. Sum of negative 11, product of negative 26. So I keep the x, and now I'm going to have an x and an x, and I'm looking for two things that multiply to be negative 26 and add to be negative 11. And just giving a little thought, a minus 13 and a positive 2 add to be negative 11 and multiply to be negative 26. And that is how number 4 factors. And that's all I got. We'll see you next time.